Good afternoon. Today we will discuss the last unit of coordinated science, the first unit in chemistry, and that is planet Earth. We will discuss the following. We will discuss the water cycle, again a little bit about the carbon cycle, the nitrogen cycle, the composition and uses of gases in air, the separation of air into its components, sources of air pollution, the problem of air pollution and their solution, greenhouse gases and climate change, water treatment and sewage treatment, the pollution of water, a little bit about metal ores and limestone and the limestone cycle, fossil fuels and the problems they cause, some alternative sources of energy, and at last we will discuss hydrogen as a fuel and a bit about hydrogen fuel cells. Now, let's look at this picture. This is the water cycle, and we will discuss different parts of the water cycle and see if you can fill in the parts at the end. What is the water cycle? Well, first of all, you need to know that water stays at Earth and it will never leave, It's constantly being cycled through the atmosphere, the ocean, and the land. We call this process as the water cycle. And how is it driven? It is driven by the energy from the sun. Think about hydroelectric plants. How does the water get there? The water cycle is crucial to the existence of life on our planet. Think about rain, clouds, Here we see a complete picture, and you need to understand what is actually happening here, And we will discuss different parts of the water cycle. But you more or less will get the idea. Let's start with the first part. What do we see here? We see the sea, we see clouds, water evaporation, precipitation. Now, what is happening? The sun heats up the liquid water and changes it into gas in the form of evaporation. Where does the water evaporate? Evaporates from the Earth's ocean, lakes, rivers, moist soil, and it rises up into the atmosphere. So, the water in the form of gas rises higher in the atmosphere and it starts to cool and becomes a liquid. How do we call this? Cooling gas to a liquid, we call that condensation. So when a large amount of water vapor condenses, it results in a formation of clouds, tiny droplets. So when the water is evaporating, it goes into the atmosphere as a gas. Now think about 1,000 meters high, it's much colder. There it is where the water actually condensates, and if there is a lot of water that condensates, it forms water. And we call this the formation of clouds. Now, when the water in the clouds gets too heavy, what's going to happen? It falls back to the earth in the form of rain, sleet, hail, or snow. Or sometimes you also see low-hanging clouds, like fog, But especially rain, sleet, hail, or snow, we call that falling down. It's called precipitation. Yeah. Now the water precipitates on Earth, and at the end it will flow back to the sea, or it is taken by the plants, yeah, and which it puts back and again in the atmosphere by the leaves. Yeah. We also use the water by trapping on its way to the ocean. Think about lakes, reservoirs, etc. Okay, because this water is very useful. Yeah, and we need water. It's essential. Yeah, we will talk about that later. Okay, so now we can complete this picture that we saw at the beginning of the water cycle. Yeah, let's see. Now let's start at the top. In the clouds we have the condensation. Now what is going to happen when rain is going to fall, or snow or hail? We get precipitation. Yeah. Now where the water evaporates, we call that transpiration from the plants. Remember, you discussed that in biology. Yeah, transpiration. Evaporation takes place from the rivers and the seas and the lakes. Yeah. Now what happens in the mountains? Yeah, look at number 2. We have precipitation. Well, we will get water runoff, surface runoff. We call that. Yeah. And this is collected in the rivers, in the sea. Yeah. Or it goes into the ground. And when it goes into the ground, into aquifers are actually underwater reservoirs, yeah, wherein the water is stored. And when the water is seeping into the ground, we call that percolation. Yeah, and we get groundwater. Yeah, so collection happens in lake, and we have nicely fresh water. Yeah, this water runs off, it goes to the sea, where we have salt water. So we have a complete water cycle. Yeah, let's say we start from the salt water, and from number 3, transpiration, because that is where the evaporation is taking place. Water is evaporating, goes to the clouds. Now remember, the water is going to cool down as a gas, and we get condensation. When the clouds gets too heavy, precipitation will take place, goes into the mountain or the land, and it will run off into lakes and into rivers, yeah, etc. So the lakes is going to be collected, yeah, where we have fresh water. And also a lot of water comes into the groundwater, which we call percolation. And then we get groundwater. And groundwater is very essential, because that is where most of the population will actually get their drinking water. Our next cycle is the carbon cycle. Yeah. Well, how is carbon taken in? It is taken in the form of carbon dioxide with photosynthesis. And don't forget, what is photosynthesis? Yeah, in a formula, CO2, carbon dioxide, plus H2O, water, makes glucose, C6H12O6, the energy in plants. Yeah. Now, the inorganic carbon is removed by plankton by photosynthesis. This is happening in the sea and oceans. Now, what is going to happen with this material when plants and animals die? Yeah, so the organic dead material from plants and animals is taken in by Earth, and it is like locked. Yeah, this organic carbon from fossils of dead plants and animals is stored for millions of years in fossil fuels. But we also have the inorganic carbon, the carbon dioxide. This is released by animals and plants by respiration. Yeah, and inorganic carbon is released also by pollution, and mainly by the combustion of fuels. Okay, Now let's look at our carbon cycle again. Yeah. So we have the photosynthesis. Photosynthesis is taking up the carbon dioxide. Then we have the decay of organisms, which we find from dead organisms and waste products. Yeah. This is coming again in a form of fossil fuels like gas, coal, or oil. No, we are using that carbon, yeah, and we are burning it, yeah, in order to release energy, and this energy, in a lot of cases, is turned into electricity. When that happens, we get combustion of organic material, and with the combustion of organic material, we get a lot of carbon dioxide, and so the carbon cycle is complete. How? There is the oxygen and the carbon dioxide in the water. Well, the plants, they take up the carbon dioxide, they release the oxygen in the air. What do we do with the air? The oxygen, we are using it for respiration, for combustion. So that means the oxygen is removed from the air. Yeah, and respiration and combustion again releases carbon dioxide in the air, and this carbon dioxide is again taken up by the plants for the photosynthesis. Okay. Remember, don't forget to make notes. Yeah, pause the video while you can, while you're watching this video. Okay. Our next cycle is the nitrogen. Where do we find nitrogen? Well, we find nitrogen in our body. Yeah. Think about amino acids. Remember, living things need nitrogen to make amino acids. They're used to build proteins. They're used to make DNA. Yeah. Now, when we look at the nitrogen gas and the Earth's atmosphere, nitrogen gas is the most abundant gas and takes up about 78% of the Earth's atmosphere. In this form, it's not usable. We don't take in nitrogen and then make amino acids. That's not possible. Yeah. Okay. So nitrogen can cycle out, we say, like mate into another compound from the atmosphere with the assistance of lightning, specialized bacteria, or human technology. Okay. So usable forms of nitrogens include ammonium, you might have heard of that, nitrite ions, nitrate ions. Yeah. Substances as ammonium are found in soil, in the waste product by many organisms, and in dead and decaying organic material. Dissolved nitrogen exists in several forms in the ocean and large water bodies. Think about nitrates. Nitrates in general do dissolve pretty good in water. So, how does this nitrogen cycle look like? Lightning produces another form of nitrogen. We have the plants. They make nitrogen. This is eaten by the animals. The animals excrete the nitrogen. There are bacteria, look at the left side, there are bacteria that actually can do nitrogen fixing. That means to make it into another form. So in the soil we get free nitrates, nitrates, and ammonia. Yeah. Now there are some special bacteria, we call them the denitrifying bacteria. They again can turn it into nitrogen gas. Okay. Now, if we look at the right side, we have special algae that can do the nitrifying of algae, yeah? And when we look again to the right side, when animals decay, they come as organic material into the soil, and again we have a cycle on the right, okay? And we have also the denitrifying nitrogen. Okay. Now, as said, nitrogen is the most abundant form on Earth. There's only certain types of bacteria that live in the soil and on the roots of plants. This can use this in a form directly from nitrogen. Okay. So, if we look a little bit at the cycle, we have the bacteria. The bacteria can make from nitrogen ammonia and nitrates. These products come to the producers, the plants, yeah. Then they produce energy. We eat the plants. We have the consumers. Remember, first, second, third consumers. They die out and they are being decomposed. And again, we have a circle. Okay. Let's have a little look at the nitrogen in the atmosphere. Okay, and we see more or less the same picture, but a little bit in a different way. Okay, so lightning and rain is can make nitrates, which comes in a form in the soil. Plants and animals that die out come in a form of nitrates in the soil. So it is important that there are nitrates in the soil. If there's a shortage of nitrates, plants will grow very badly. Yeah, very bad, like Trump says. Yeah. So you might remember it has been discussed that there are some soils that actually do not contain nitrates. So how do they get their nitrogen? Well, actually, they do this by capturing animals, yeah, and they contain amino acids and can be turned into nitrates, which are useful for the plants. Okay. In our next topic, we will talk about renewable versus non-renewable sources. And we actually can divide material sources into three types. We have one, the non-renewable source. Second, potential renewable source, and non-renewable sources. Okay. Now, the non-renewable sources are those that are in fixed quantity in the Earth's crust. But it's not going to change. Well, it is going to change because we're going to reuse those non-renewable sources, yeah? Remember which non-renewable sources we use. Some non-renewable sources are non-metallic and metallic minerals, fossil fuels, which are formed over millions of years, and they are used up faster than they are being formed. Okay? Fossil fuels are formed over hundreds of millions of years. So when we use them up, they're actually used up. So that's why we call them non-renewable sources. Okay? Then we have the renewable sources. Those are essentially not running out, like wind, tides, and solar energy. Then we have the potential renewable sources. They can be renewed, but they run out if we use them more quickly than they are renewed. And think about the following. We're thinking about fresh water, air, fertile soils. plant and animal biomass, okay? These are potential renewable sources, yeah? Now, what are the solutions for our resources so that they don't get depleted? Yeah? They can be depleted. One of the things is recycling. Yeah, so we can reduce the use of material sources by recycling or reusing. Yeah, a lot of material sources can be recycled, metals and plastic. Yeah, fossils actually can be a bigger problem. We always need energy. Yeah, so what can we do with the fossil fuels? We use renewable sources like wind energy, hydroelectric plants, solar energy to create energy so that we need less energy from fossil fuels. Okay? Okay, let us look at the atmosphere. Let us look at the composition of air in the atmosphere. We have about the most abundant 78% of nitrogen. We have 20.9% of oxygen. Some other gases like helium, ozone, etc. A little bit more than 0.17%. Argon 0.9% and carbon, you might be surprised, 0.03%, but it has a huge impact, which we'll talk about that. It's actually increasing, and you probably know why the carbon dioxide is increasing. Okay, so air is actually a mixture of different elements and compounds. Okay, now what are the uses of air? Well, we have one, nitrogen. Nitrogen is used as ammonia and fertilizer, which is produced by the Haber process. We use liquid nitrogen, is used in cryogenics, yeah, to keep things at very low temperature, for example, to store embryos and tissues, yeah. Also, nitrogen is a very unreactive gas, and it is used in sealed packages to keep oxygen away. Then we have oxygen. Oxygen is mainly used in the production of steel from cast iron, and it is used in hospitals and stored in cylinders to support people with breathing problems, especially now, if you might have heard. Then we have some other gases like argon and neon. They are noble gases and they're used in lighting. Maybe you have heard about neon lights, yeah, and argon that is used in bulbs. Now, how can we separate all these gases? Now, let's look at some characteristics, some specific details of the different gases. We can separate them based upon their boiling points. And look, let's look at the boiling points. And we see some pretty big differences in boiling points. Okay. Carbon dioxide has a boiling point of minus 32. Xenon minus 108. Let's look at oxygen already, minus 183. Nitrogen minus 196. Which process do you think we can use to separate the gases in air? Remember what they use to produce different products from oil? Exactly. We call that fractional distillation. Now, it's a little bit different with air. First of all, the first thing that we do is that we cool the air so we get like liquid air, and then we slowly warm it up. Okay, Now, from the most important gases that we use, which one is going to boil first? You should look back a little bit in the former slide. We get first nitrogen. If the temperature increases, we get argon and then oxygen. Yes, we call this boiling off. Okay. Air pollution. What is pollution? Pollution describes actually an undesirable factor of a pollutant that is added to the air or the water or the soil. In this case, we discuss the air pollution. Yeah? Many gases come into the atmosphere accidentally or deliberately. Accidentally by volcanoes, for example, or just gases released by the soil, yeah, by the earth. Okay. The main source of the problem of the gases are coming from exactly burning fossil fuels. Yeah. Well, you need to know that fossil fuels, besides carbon and hydrogen, they also contain sulfur and nitrogen, and they form also trouble. Okay, and we'll discuss that. Yeah. When we combine the sulfur and the nitrogen, they will turn into acid rain. Okay. So when we have sulfur reacts with oxygen. It forms sulfur dioxide. The sulfur dioxide reacts with water to form sulfurous acid and sulfuric acid, and comes into the air. We also have the nitrogen oxides. Nitrogen plus oxygen makes nitrogen oxide, and again mix with water and we form nitric acids. Okay, where does it come from? It comes from burning fossils from the car, in factories where they use fossil fuels. Yeah. Things that we can reduce is actually by taking out the sulfur from the fossil fuels. Yeah. Now, how is this acid rain coming? Well, think about the sulfur oxides and the nitrogen oxide. They're going into the air. They're going to combine in the air, which we discussed already in the water cycle. They come into the rains, and they fall down as precipitation. Yeah. What will happen if we have acid? Then the pH is going to drop. Okay. And this has a major effect on ecosystem. For example, decreasing pH levels in lakes and streams. Yeah. They threaten the water supplies of specific habitats. Lime buildings and statues are worn away. Yeah. Acid rains, they kill trees, and they have an effect on the growth of plants. Yeah. These are typical pictures of where acid rain has been taking place. No leaves trees are worn out. In the next picture you see two statues on the left side and on the right side. On the left side we see acid rain before and after, and then we have smog, which is mainly created by nitrogen oxide. Happens also in Saigon. Sometimes on a clear day when there is no rain, we get a lot of nitrogen oxides and like a brownish, cloudyish, air, and sometimes you cannot see 1 kilometer further. Okay. How can we neutralize this acid rain? And they do, especially in certain forests, by using limestone. But of course, prevention is better. Okay. Another way to reduce some toxic gases from the car. One of the toxic gases that a car produces is carbon monoxide. Now, when does carbon monoxide occur? when there is actually not enough oxygen, and we call that incomplete combustion, and then we get carbon monoxide. And carbon monoxide is very toxic. You cannot see it, you cannot sniff it, you cannot smell it, and it can actually take over the place of oxygen in your blood. It's much stronger and you could suffocate. Okay, now in cars there are catalytic converters. Yeah, it's like enzymes in body but not being used up. Yeah, and instead of nitrogen oxide and carbon monoxide, you get carbon dioxide and nitrogen again. Okay. Now let's look at some other causes of burning fossil fuels, and let's look what is the effect of carbon dioxide on the temperature on Earth. Yeah. When we look at the table, we see from year 1979 and the carbon dioxide, which is expressed in ppm. ppm means actually parts per million, and we see that from over again, and I showed you this also in the slideshow from our last topic, that the amount of carbon dioxide has been increased, and we know already what is actually the effect. Yeah, we get the greenhouse effect. Yeah, and we know already how it works. Yeah, so how can we look back in the past? What was the amount of carbon dioxide in ppm in the atmosphere? Now, researchers have gone to the Antarctic and the Arctic ice, and they have been drilling holes into the ice sheets. Now, when you're drilling a hole into the ice sheets, you're actually looking into the history. And think about this. Snow has been falling down, let's say 100,000 years ago. With that snow, some air is trapped, and another layer of snow, and another layer of snow, and then we get these big ice sheets. So at that time of the period, you can actually see the content of the air. So it's like looking into the history, and we can look back, let's say for example 100,000 years, and what was the concentration of the different gases in the atmosphere. Okay, so we actually can look way further back, even over a period of 130 years. Yeah, so if we see the left picture and the right picture, yeah, which label you think goes to each picture? We have 200 ppm and 300 ppm. The 200 ppm to the left, and the right one 300 ppm. That is nowadays. Okay, let's say that on the left side we had the old ice age. Okay, now how does the greenhouse effect occur? Well, simple. Heat is coming from the sun. It's taken up partly by the earth, and the heat is again reflected back outside. Now, when there is more carbon dioxide, then heat is trapped by the air in the atmosphere. Yeah, so this is one of the greenhouse gases. There is another gas that is actually much stronger, that is the methane, but the concentration of methane yet, I have to say, is very low. But the amount of carbon dioxide that we have been produced, has increased the concentration of the carbon dioxide. Because of the increase of the carbon dioxide, the Earth is warming up. Yeah. So when we get more carbon dioxide, there's less heat loss, which means the Earth is getting hotter and hotter. Now, what are the effects of the global warming? Well, you know them already, and actually you can see them pretty close by here in Saigon. Yeah? Now, first thing is that we get warming of ocean. Yeah, the oceans have absorbed heat, and much of this heat is absorbed in the water, and actually the water only already expands by the heating up of the water. That means increase of water level. We also have the shrinking ice sheets, yeah, which we see in Greenland, Antarctic ice, the Arctic ice, yeah. They have decreased in mass. They go into the sea, which also has an effect on the increase of the water levels at sea. Yeah, and next picture taken not too long ago, about a couple of years ago, and we see just flowing melting water on the Greenland ice sheet, and this hasn't happened 50 years ago. This is really recently. Okay, now what are the effects? First of all, we get a climate change, which leads to extreme weather changes like extreme droughts or extreme rainfall. We get ocean acidification because the carbon dioxide content on the Earth's ocean has been increased. This carbon dioxide is dissolved in water and forms carboxylic acid. Carboxylic acid is an acid which gives a decrease in the pH, and we get like coral bleaching. Yeah. Also, the temperature has an effect on the growth of the coral. Okay, coral is very sensitive. Okay, now we go to our next topic, seas and rivers. Let's first look at this picture. And actually, you think there's a lot of water now, like in the river and the ocean and the lakes, etc. But let's look at all the water that we have. The oceans only take already 97.4% of all the water. This all water is salt, which leaves us with 2.59% that is like, we call it sweet water or not salt water. Now, all of that, most of it, we see in ice caps and glaciers. And then for the rest, we see it like in groundwater. And this groundwater, like in lakes, rivers, in the atmosphere, and in soil moisture. Now, we have 3% of the fresh water. It's still enough. But the problem is it's not always at the right places. Yeah? We know that water is essential for life, but it also can carry diseases. Yeah? Water poisons millions of people per year. So, the water, can we drink it from the river? Or just pump up water from the ground? I don't think so. So that means we need to purify water. Yeah? The water from the river and the seas, they contain salts, solid particles, and bacteria, and they need to be treated before we consume it. Yeah? So, solids, bacteria, harmful chemicals, pesticides, which come from, and herbicides, which come from farming, they need to be removed. Yeah? And this is a long process of cleaning, yeah, before we even can use water to consume. Okay, and there are parts like I lived in an island in Curacao. Well, if you're living in an island and there's hardly any precipitation, where do you get your water? Exactly, you get your water from the sea. So that means it needs to be desalinated. Yeah? Okay. Now, what are the problems what problems are we creating with the water? Well, water pollution. What are some water pollutions? Nitrates. They come from fertilizers used in farms, and they seep out and they come into rivers, and they are growing algal growth. We have industry discharge of pollutants. We have untreated water sewages, which can lower the oxygen levels and spread of bacteria. And also, where they use fossil fuels to make electricity, they need a lot of cooling water. Now, this cooling water they take from the sea, and then they bring it back off from the river, and they bring it back to the river. That means that the water in the rivers is going to increase, which lowers the oxygen level, okay, which has an effect on the plant and life of animals in the rivers, okay. The Earth's crust. Do you know how thick is the Earth's crust? And when we look at the Earth's crust, it's actually the outer thin layer. Yeah. In the Earth's crust, we have about 8 elements that make up of 98% of the Earth's crust. You could think about which element these are, but they are mainly in a form of a compound. The Earth's crust is about 5 kilometers under the ocean, certain parts of the ocean, to maximum 50 kilometers. Okay, so it's very thin if we look at the diameter of the Earth. The Earth's crust contains a lot of valuable metal ores, different types of compounds, and limestone. And we're going to look at limestone. And why is limestone so important? Limestone is used in many industrial. We use it for buildings, for roads. We use it for neutralization, acidic soil. We make, in combination with sodium carbonate, we make glass. We use it in the steel industry to remove impurities in the surface. We can make cement with it, which we need for making walls. We use it for paper. Okay, so there are many different types of uses for the limestone. Now, we could do an experiment in the class to actually show a little bit about the limestone cycle. Let's look at this picture. Now, think about limestone mainly contains calcium carbonate, CaCO3. Okay. Now, when we look at the first part of the cycle, number 1, yeah, calcium carbonate, when we heat it up, you might remember that from chemistry class last year, it can be turned into calcium oxide. We call that quicklime. During that process, carbon dioxide is given off. Now, when we add a little bit of this water to the calcium oxide, alkaline, we get calcium hydroxide. This we call staked lime. Okay, we can even add more water and add a filter, and then we get calcium hydroxide, which you might know, which is lime water. And you know how you can find carbon dioxide from your breath, yeah, by using lime water. So you add carbon dioxide to the calcium hydroxide solution, and again we get like that precipitation in the lime water, that cloudy thing. That's calcium carbonate. Yeah. Let us have a look at the fossil fuels and the problems with it. Well, we know fossil fuels are mostly used as energy, yeah, and they create a lot of problems. We discussed that already in the acid rain and the global warming, yeah. When we look at our energy sources, we use mainly fossil fuels in the form of petroleum, coal, natural gas, yeah. Now we have some other parts that we use, like hydroelectric power, nuclear energy, and renewables, okay. Some of the renewables are solar energy, biomass, wind power, hydroelectric power, and geothermal energy. So, in order to reduce the problems with the fossil fuels, we should use more renewable energy to reduce these fossil fuels. Yeah? One of those fuels that we actually could use and make pretty much easily, but has its problems, is hydrogen. The advantage of hydrogen is that it doesn't cause any acid rain or any global warming. It only produces water. And actually, hydrogen produces more energy per gram than any other fuel. More than gasoline or methane or pentane or butane. Yeah? Hydrogen can be produced in different ways. It can be used to power cars by using hydrogen fuel cells, which will generate an electric motor. In order to understand that, you have to do A-level chemistry, but we will discuss a little bit the hydrogen fuel cell. It's like a cycle of hydrogen going in, going out, oxygen in, going out, and there's like a special catalyst that we use, and it can produce electrons, and the electrons is actually electricity. Yeah, so we get like generation by the reaction of hydrogen, which produces water and oxygen. And the advantage is that these cells, like in electric cars, we don't need to recharge them. It is a continuous process. Now, hydrogen is easy, everywhere available, because we have water. And water is H2O, which contains a lot of hydrogen. Now, the advantage are it is renewable if produced by solar energy. Has a lower flammability than gasoline. It's virtually emission-free, no emissions of carbon dioxide, and it's non-toxic. What's the disadvantage? It is of course non-renewable if we use other types of energies like nuclear energy or energy from fossil fuels. Another problem is that we need a large fuel tank. This hydrogen is very difficult to store. Yeah. At this moment there are a few filling stations, yeah, wherein we can top up the hydrogen, and there needs to be a redesign of the fuel system. And at this moment it's currently expensive. Okay. Which brings us to our last part of planet Earth, and that is land pollution. When you see this picture, it makes you think, no? We just dump our waste everywhere. Yeah, most of our waste is buried in landfills. Yeah, this can be toxic radioactive waste, which can make land actually unusable. Okay. Normally, companies are required by law to treat their waste so that it makes the waste harmless. Domestic waste should be recycled, and if we cannot recycle it and avoid dumping it, yeah, because when we just dump organic waste, it can produce methane, which is a strong greenhouse gas, so we better burn it and use that energy. Okay, this is the end. This is the last slideshow, and we will discuss it soon in one of our online lessons.